All right, so I'm going to go over the relative maxima, minima, increasing values, decreasing values, and constant intervals for the graph. So when we're looking at graphs like this, we'll be able to tell all of that stuff. Relative maxima just means like if I'm looking at a graph that looks like this. Because this has arrows, the actual maximum value is infinity, but we don't know, like, well, I guess we kind of know what x value that's at. Um, there could be a limit, so we don't know. Anyways, the whole point is that when this happens, it's way, way, way off the graph. But what we can see is we can see this maximum value right here. So relative to the graph, relative to the values that are measurable, what is the maximum value? And the max is the y. But we have to have the x value at that point. So what we're going to do is it's going to be, on this example, it's going to be 0 for x. And let's say that y is 5. So that would be your maximum value, relative maxima. So fairly simple. Relative minima would be the lowest. If these are the exact same, then they would both be relative minima. So this one would be maybe -2 on the x and 1 on the y. And this one would maybe be 3 on the x and 1 on the y. So they both would be relative minima, meaning the lowest point that we can see. And the reason that we say relative is same thing. The graph could be going like this. And so the minimum value is actually negative infinity, but the minimum value that we can see is right there. I realize that I drew my two graphs the exact same. It does not have to be like that. It could be something like this. And my relative minimum is right here. Hopefully on the graph, you'll be able to tell what is the exact point. I will put the hash marks in like I did on these examples so that you can find them. Just count them out. That's essentially it. If I told you a function and I told you the function has a relative maxima, the function is, and I say f of x equals 3x squared plus 6x plus 9, and then I say the function has a relative maxima at x equals 2, then all that you're going to do is you're going to take the x and you're going to plug it in. Your point is going to be 2 comma something, and you got to figure out what that is. So we're going to go 2 squared plus 6 times 2 plus 9. It's 4, 12, 12, 24, 33. So that's really it. If I give you a function and a value for the x or the function and the f of x at that value, then you just need to you need to see what the x would be. But I probably won't do that. So let's just worry about it this way. Increasing and decreasing values. So we're gonna talk about our domains. On this graph, I'm gonna cut it into increasing and decreasing values. We read the graph from left to right. So from left to right, this is decreasing right here. That's one section where the y value is decreasing. So I would go from negative infinity on my x to whatever this x is, which we said is -2. That is included. So from negative infinity to -2, this graph is decreasing. Then it starts increasing from here to here. So it's going to increase from -2 included until that's 0 included. It's going to decrease again from 0 to 3. So this is also over here from 0 to 3. And then it's going to increase again from 3 to infinity. So this is decreasing. This is increasing. And this one actually didn't have values where the function was constant. Where the function is constant is where it would like flatline off. So if I had something that looked like a graph that looked like this, it's increasing from here to here, and then it's constant from here to here, and then it's increasing again from here to here. So that's what a constant would look like. Constant would just be flat. So when we're doing the intervals, we're going to use interval notation, hence the name being in both spots. And that's what we're looking for. So I'm going to do this first one. Relative maxima on this guy is the highest value. The highest value is at y is 1. That's actually going to happen on a domain from 1 to 4. So I need to do it like this. X and y follow the rule that 1 is less than or equal to x is less than or equal to 4, and y equals 1. So that gives me the rule for all of the x's, and this gives me where the y, oh, the y is 0. I apologize. The y is 0, not 1. I don't know why I said 1. That was dumb. Okay, so I'm just looking at what is y at the maximum value, and then what are all the x's. I had to write it in this form because it wasn't just 1 point. My relative minima is just 1 point. It's this guy right here. At y is negative 1, 2, 3, 4. And x is negative 1, 2, 3, 4. So this is the maxima relative. And this is the relative minima. Increasing values, it's increasing from here to here. This is at x is negative 4. This is at x is 0. And actually it keeps increasing until x is 1. So I'm going to increase from negative 4 to 1. And then it's going to be constant from 1 to 4. Constant from 1 to 4. And then it's going to decrease from 4 to infinity. So decreasing from 4 to infinity. And that's just how we're doing this stuff. So hopefully that makes sense.